What's up, everybody? This is Danny Mathematics. Today, I want to go over two examples of how to add and subtract negative and positive fractions. Once again, how to add and subtract negative and positive fractions, okay? So let's go ahead and start off with the first example. I have 2 and 1/2 minus a parentheses negative 1/8. Once again, 2 and 1/2 minus a parentheses negative 1/8, okay? So I've noticed in this problem, guys, I'm subtracting a negative fraction or a negative value, okay? I'm subtracting a negative value, okay, or a negative fraction. So I really want to figure out what I'm actually doing or what's the actual operation within this problem, okay? So once again, guys, remember, whenever you're dealing with negative and positive numbers, whether they're decimals, integers, fractions, or whatever, whole numbers, you have to utilize the tic-tac-toe tool, okay? So once again, I see that if I have two negative signs, right, then for me to tic-tac-toe, both of those signs have to turn into a plus sign, okay, or a positive sign. So what I'm going to do is, guys, I'm going to cross out these two signs, okay, and then they are going to turn into this plus sign or this addition sign. Okay, so now all I need to do, guys, is just bring everything else down. So once again, I have 2 and 1/2 plus a positive, because remember, this negative sign one away, okay? Plus a positive 1/8. Okay? So, in order for us to actually add these two fractions, guys, the denominator, which is the bottom part of the fraction, has to be the same number or has to be the same value, okay? So we need to figure out, guys, what is the least common multiple of 2 and 8? Okay? So once again, I'm just going to count up by twos. I got 2. I got 4, I got 6, I got 8, I got 10, and etc., right? Let's count up by 8s. I got 8, I got 16, I got 24, etc., right? If we notice, guys, the least common multiple, right, between 2 and 8 is 8. All right? 8 is the lowest number within this set of numbers that is the same in each set, okay? So 8 is the lowest least common multiple within the set, right? So the 1/8 already has an 8 within the denominator, right? So I have to change 1/2 and I have to multiply by a number to figure out what do I have to multiply by 2 to get to 8. Now let's look. 2, 4, 6, 8. For me to get to 8, I have to multiply 2 by 4, right? So what I need to do, guys, is just multiply 1/2 by 4. So I'm going to multiply the numerator by 4, which is the 1, and the denominator 2 by 4, okay? So now let's go ahead and do that, guys. So now I have 2, and 1 times 4 is 4. That's the numerator. And the denominator, 2 times 4 is 8. So now both fractions has the same denominator, which now we can actually add these particular fractions together. Okay? Now, we only have one base, which is 2, right? The second fraction doesn't have a base. So it's actually saying 2 plus a base of 0, which is 2. And I'm actually going to make the base be pink so y'all can clearly see what I'm talking about. So once again, the first fraction has a base of 2. The second fraction doesn't have a base. So it automatically has a base of 0, right? So 2 plus 0 equals 2, okay? Once again, the denominator always stays the same. So it's still over 8. And now all we have to do, guys, is just add the numerators, right? Which is just 4 plus 1. All right? So, and I see that we don't have to simplify, guys. So the answer to this particular problem is 2 and 5/8. Okay, 2 and 5/8. And let me just go ahead and just give you a visual of what I'm talking about, guys. So once again, 2 is the base. I just want to just go over that. Meaning that it's a whole, right? It's a whole number of 2. And this right here is the actual fraction part, even though all together is actually a fraction altogether. But let me just go ahead and just draw this as an illustration, okay? So 2 and 5/8. Let's just act like we have 3 pieces. So this is a piece, this is a piece, and this is a piece. And the denominator lets us know the amount of slices within each piece, which each piece has to have 8 slices. I believe that's 8, okay? All right, so each pizza, or you could say pie, or whatever you want to call it, has 8 slices each, okay? So the 2 represents that I have 2 whole pieces, or 2 whole pies, right? Meaning that I have all the slices within the first 2 pieces, or the first 2 pies, okay? So I'm just gonna shade in all of the slices. So this is where my base of 2 comes from, because I have 2 whole pieces, or 2 whole pies. So this is where my base of 2 comes from. Now the 5/8, guys, come from this pizza that's already been eaten on, right? Let's just say that out of the 8 slices, we only have 5 remaining slices. So we only have 5 remaining slices because 3 slices we're eating, right? So this right here is the fraction part of 5/8, because within this particular pie or pizza, I only have 5 out of 8 slices. So I have 2 whole pieces, which is the 2, that's the base. And the third pizza, I only have 5 out of 8 slices. So I'm just giving y'all an illustration of how that looks, okay? Now, let's go to the second problem, guys, which is I have a negative 4 and 1/7 plus a parentheses negative 4 and 5/6. Okay, once again, I have a negative 4 and 1/7 plus a parentheses a negative 4 and 5/6. Okay, so the first thing I want to find out, guys, is what does it mean to add a negative? What does it mean to add a negative? Once again, you should already have a tic-tac-toe drawn. Positive, positive, positive. Okay, negative, negative, right? So if I have a plus sign, right, and the second integer, or the second fraction rather, is a negative, right? A positive and a negative, in order for me to tic-tac-toe, I have to subtract. So both of these signs turn into a subtraction sign. Okay, and they both go away. So now I just bring everything else down. So I still have a negative 4 and 1/7 minus 4 and 5/6. 4 and 5/6. So once again, I still have a 4 and 1/7 minus a 4 and 5/6, right? Now, the next thing that I want us to do, guys, is now we gotta actually solve, okay? So whenever we have negative and positive numbers and we're adding or subtracting them, the next step that we need to do is we need to circle each value along with the sign that is associated with it, or that's in front of it. So I have a negative 4 and 1/7, knowing that that's a negative. And I have a negative 4 and 5/6, knowing that that's a negative, right? Now, let's go ahead and create a negative and positive t-chart. Because we're going to figure out what side are we going to work on, okay? So I got a negative and positive t-chart, okay? Now, Since both values are negative, we automatically know that we want to work on the negative side because both values are negatives, okay? So we're automatically going to work on the negative side, okay? So I have a 4, and also this one is the bigger fraction. If we drop the sign, this will be the bigger fraction, but it really doesn't matter because both of them are negative. So once again, I have a 4 and 5/6, and I have a 4 and 1/7, okay? Because they are both negatives, right? That means that we must add because they have the same sign. So we have to add these on the negative side, but since we're operating on the negative side, we know that our answer is automatically going to be a negative, okay? So now, let's actually go ahead and do that, guys. And I'm actually going to do it over here. So, once again, we already know that we're working on the negative side. So, once again, we have a 4 and 5/6 plus 4 and 1/7, okay? 4 and 5/6 plus 4 and 1/7. And let me just go ahead and make the bases be pink so we can identify the bases, okay? Once again, guys, in order for us to add fractions, the denominators have to be the same, okay? The denominators have to be the same. I have a denominator of 6 and a denominator of 7, okay? So let's find the least common multiple of 6 and 7. I'm going to count up by 6. 6, 12, 18, 24, 30, 36, 42, 48, and etc., right? Now, let's count up by 7s. 7, 14, 21, 28, 35, 42, 49, and then so on, right? The only number so far that I see within both sets is 42. All right? So in order for me to go from 7 to 42, I had to multiply by 6. In order for me to go from 6 to 42, I had to multiply by 7, right? So what we're going to do is, guys, we're going to do this. The fraction with the denominator of 6, right? We're going to multiply by 7 because 6 times 7 equals 42. And the denominator of 7, that particular fraction, we're going to multiply by 6 because 7 times 6 equals 42. All right? So now let's go ahead and solve. So I still have a base of 4. 5 times 7 is 35. And we know that 6 times 7 is 42. So we're good. So that converts into the fraction of 4 and 35 over 42. All right. The second fraction still have a base of 4. And 1 times 6 is 6. And then, of course, 7 times 6 is 42. Now, the only thing that we need to do, ladies and gentlemen, is we just need to add the bases and add the numerator, which is the top part of the fractions. Okay? Now, a base of 4 plus a base of 4 equals a base of 8. Once again, we're still over 42 because the denominators stay the same. Now I'm going to add the numerators. 35 plus 6 equals 41. Right? But remember, guys, we was working on the negative side of our chart, so we have to add a negative sign to our answer. So our answer is actually a negative 8 and 41 over 42. That is our answer, guys. So once again, guys, these are 2 quick steps of how to add and subtract negative and positive fractions. And I know this is a concept that most 7th graders and 8th graders are working on currently, okay? Thank y'all for tuning in today, and I will come out with more examples later on this week.